Okay, this is section 4.4, isosceles triangles. The proofs and things are getting a little bit more complicated here, so easy part of chapter 4 is over. So before this section, we are going to talk more about why we are doing proofs. So do you remember there was a warm-up on the other packet that I asked you to think about a situation where you had to convince someone, and we didn't really go over that in the class. So I want you to refresh that memory and come prepared to class to share that, okay? So we talk about that before we start the class. And this one, so here's isosceles triangle, okay? And PR is PS. And if I fold this triangle in half at PQ, these two triangles actually is going to overlap. Okay, so based on this information, without looking inside this packet, try to list as many conclusions as you can draw from the isosceles triangle above. So one of the things, for example, that I want you to think about is this is going to overlap with this, so that means these are congruent, right? So that's one thing that you can observe. Triangle PRQ is congruent to triangle PSQ. And from there, there are a lot of things that you can conclude. So I wanted to list them all that you can think about it, okay? And you will see more of that in a packet. Okay, so we are here, and these two, actually, every single of these sections are very proof heavy, and the diagrams get a lot more complicated than the one that we've done so far in chapter 4. We're going to do a quiz here, okay, and then a test at the end, okay? Otherwise, doing all 4 together would be too much. Okay, so there is one objective in this packet, and that is apply the theorems and the corollaries about isosceles triangles. Okay, you remember what isosceles triangles are? It's a triangle with 2 congruent sides. Okay, so here's the vocabulary of isosceles triangles. These congruent sides are called legs. And these, so this is the vertex angle. That's the vertex angle. So the vertex angle is between the 2 congruent legs. And then the other angles are called base angles, and that is called base. So even though, let's say, isosceles triangle is orientation is like this, this is still a base, and this is still a vertex. Okay. So these names are not based on the orientation of the triangle. That's based on where the congruent sides are. Okay. And here's the conclusion. So these 2 triangles are congruent. So these angles have to be congruent, right? These angles have to be congruent. Those are the base angles are congruent, right? If they are overlapping. And this have to be 90 degrees, right? And also this have to be a midpoint, right? So there's a triangles are congruent. These are this is angle bisectors. This is a segment bisector. These are right angles and congruent, and base angles are congruent. Okay, so those are the characteristics of isosceles triangles that we're going to prove in this packet. Okay, all right, so here's the theorem 4.1, the isosceles triangle theorem. This is the first theorem that comes out in chapter 4. So far what we used were postulates. Okay, so if 2 sides of a triangle are congruent, then angles opposite those sides are congruent. So angle opposite is this. So the 2 base angles are congruent. Okay, so given AB is congruent to AC, the angle B and angle C are congruent. So here's the plan of proof. you can show that B and C are corresponding parts of congruent triangle if you draw an auxiliary line that will give you such triangle. So this is auxiliary lines. Okay. For example, draw a bisector of angle A. So this line is a bisector of angle A. So these have the same angles. Okay. So I am going to write the statement and some of the reasons, and then you do the rest. Okay. So one is given. Okay, so the goal is to make these two triangles congruent and use corresponding parts of congruent triangles to make these congruent, right? So that would be one side here. Okay, and then angle bisector of angle A intersect segment BC at D. And the reason for this is a protractor postulate, which it says that an angle has exactly one angle bisector. Okay, you don't need to remember this. You don't have to produce this kind of proof on your test or quiz. So, but that's the reason that you can draw angle bisector from here, and then that will have to intersect with segment BC at some point. We call that point a D. Okay, and there's only one unique such line because there's no two angle bisector you can draw from the one angle. So that's what this is. Okay, and the 3 angle BAD is congruent to angle CAD. You can do the reason there. 4 segment AD is congruent to segment AD. And 5 and 6, I think you can do the statement and the reason both for 5 and 6. So here we got an angle here, and here we got a side, right? So you know what to do. Okay, and here are corollaries related to isosceles triangle theorem. By the way, this is called isosceles triangle theorem, which is that if the triangle is isosceles, the base angles are congruent. Isosceles triangle base angles are congruent. Okay, and here are 3 corollaries, and I think thinking through how these corollaries are true is in the part of the exercise. So an equilateral triangle is also equiangular. Okay, so if it's isosceles, the 2 base angles are congruent, and if not just isosceles but it's equilateral, then all 3 angles are congruent. How do we prove that? Think about it. An equilateral triangle has 360 angles. So once you prove this one, that's not hard because 180 divided by 3 is 60. Looks a little bit out of focus. Is that better? Okay. The bisector of the vertex angle of an isosceles triangle is perpendicular to the base at its midpoint. Okay, so how do we prove that? You remember if, we said that right here, these 2 angles, these have to be 90 degree because those are linear pair, right? And adjacent and congruent, right? You remember what that was called, so that's what this is. But these are part of the exercises, okay? And here is the theorem 4.2. And theorem 4.2 is a converse of isosceles triangle theorem, in which that if the base angles are congruent, then sides are congruent. Okay, so the isosceles triangle theorem goes from if it's isosceles, that means the sides are congruent, then base angles are congruent. if you go from the base angles to the side, that's converse. Okay, so if two angles of a triangle are congruent, then the sides opposite of those angles are congruent. So if B and C are congruent, then AB is congruent to AC. And Prandtl proof. You can show that AB and AC are corresponding parts of congruent triangles. So draw a line as auxiliary line, show that, again, it's an angle bisector. Okay, and then how do we prove that? I think you can do this one. You are trying to prove, okay, so what you are trying to prove is that these are congruent, right? That's given, right? And this is the auxiliary line that we draw, and then because it's angle bisector, these are congruent, okay? And then this is shared. So that's an angle side, but you know what to do with angle side. So I want you to write this one. That's homework. You can do this one, I think. Okay, and the corollary for 2 is equiangular triangle is also equilateral. This is the converse of this corollary right here, the corollary 1. That equilateral triangle is equiangular. Here is the equiangular triangle is equilateral. Okay. Right. So I think you can do all these. These are kind of easy exercises. Okay. And then here, see, explain how corollary 1 follows from theorem for 1, corollary 1, theorem for 1, for 2. So let's do these in the class, okay? In the class. We talk about this tomorrow. And you do these for homework. Okay. Should we do a sum? Let's see. If given two congruent angles, how name two segments that must be congruent? Okay. So for example, let's see, 3 and 4. If 3 and 4 are congruent, then the congruent segments are this and this, right? So the segment KM is congruent to segment KN and so forth. If statement MK is NK, if and only if the 3 and 4 congruent, is that true or false? I want to do this one too, okay? Right, and here are the exercises. So we do these in the class, and I think, look at it. There are a lot of, especially towards the end, look at these diagrams. It gets a lot trickier. Look at these here. See these diagrams. So we spent 2 days on this packet, okay? All right, so I will see you in the class.